Hello there. Today, I want to introduce the other topic of digital information. So, it will be storing text in binary. This is the important subject again. So, all we will solve together. Anyway, let's let's start it. And really, just I won't start here. Maybe here, right? First, I will write this title. I will say storing text text in a binary. Okay, this is our subject. Today we will speak about it. Say red, right, just come down. Okay, let's come here and we will write lots of things today, but what I want to do, sometimes I can check some information in Google. We can check there, maybe then write. Anyway, we will do all together. Just don't worry about that. First, I will start with this. Let's say computers store more more than more than just numbers in binary. Just numbers in binary. Okay. But how can binary numbers? But how can binary numbers represent non-numbers such as such as ladders and symbols? What do you think about that? All the time you see an emoji and some kind of different Chinese word, Japanese words, and really, what do you think about that? It's not like Latin alphabet, right? So something different there. It's not Latina and it's not like English words. Okay, for German words, same. There is also some different words, right? Differentiation too much. I mean, anyway, we will speak all about them. So I will say, just put here question mark, and say as it turns out, yep, as it turns out, all is requires, all is requires, yep, requires is a is a bit of human cooperation is a bit of human cooperation, right? It's something like that. And I think I wrote, no, I'm not wrong. we must we must agree agree on or on, but I can write down encodings mapping from a character to a binary number. That's good. Binary number. Read it something like that. Yep. Now the subject is that today we will together. Let's say here a simple encoding. Okay. Let's do it something like that. And let's come left and just do it blue. Okay. And what I want to do, I will take three example. I can say emoji, maybe. And what we can take from here, if there is some list about emojis, I think too much. let's say, but have you seen this UTF, Unicode, system in Unicode? All of them. Anyway, we will speak all about these emojis because our subject related with this thing. Okay, let's come down and let's come down and we will look what we need here. Yes, maybe come down. This is all package. Okay, they are just in one package, in different package. Each package represent different emojis. I mean, let's come down. Lots of things here. Maybe you didn't see in your phone too. Just you can check really here all this emoji. Still, have you see? Still is coming down. Too much things. Still, right. Just come here. We will look what we need from here. I think up here we need which one? Maybe I don't know really. We can select the good one from here. Which one can be our need? So I really am not sure. I'm just checking here what we need here. Okay, it's just some emoji here. Okay, let's go up. Okay, just what I want to do here. Just I will come back and let's select some emoji here. Yes, just tag these ones from here. Okay, let's come here. Okay, just I will represent with something, but just don't think like that. Okay, what I want to do now, I want to say we can. Let's do that. Black color. Come back. Say black. Okay. Yes, say we can invent this. Invent this simple. So also I think I forget to write upside something about them. Let's come here and say, for example, why still this? I don't understand why black. For example, for example, what if we wanted? What if we wanted? What if we wanted to store the following? To store the following symbols in binary. Symbols in binary. Okay, like that. I mean, have you seen it's three emoji? It's all about that. We will speak. Let's come down and let's write here again. This we can invent. I don't understand why this we can invent. Anyway, I will solve this problem with this idea. Okay, we can invent. Let's come here and say why really? It's crazy. I just don't want to write with this. I don't know what happened. Really. Say yes, we can. Right. It's good. Invent this simple encoding. This simple encoding. Okay. What we can do now to represent this thing? I will do something. Just check it. Binary. This is the binary. This is the symbol. Okay. And let's come down for say for 0 1, it's just 1. This one, so just think like that, okay? This is not that normally. This one is this symbol, and this one will be this emoji, okay? Let's come here and put there. So also let's come down, say 11. Still, I don't know why this blue. Let's come down. Okay, let's come here and say for that this one is that. Just we are inventing now, okay? Just like that. You can do also your emojis really. Then you can implement for encoding. So there is some package I told you. So we can speak later about that. Let's say uh, just say right. If I delete, what will happen? Yes. Let's say okay. Let's call let's call let's call it the let's call it the HPA encoding, something like that, okay? Also, you can put another name, it's really not important. Let's say it helps it helps for encodings to for encodings to for encodings to have names so that have names so that programmers know they are using know they are using the same encoding. Yep. Okay. If programmer programmer let's come down. Okay. If not programmer, if a program computer program needs to store the let's say this emoji, okay? I understand when I click this, then this coming blue. Anyway, needs to store this one. Let's say again black. This one symbol in computer memory. So it can store 10 instead. When the program needs to display, when the, I mean 10 is that, okay? I told you it's like 2. When the programs, let's say when the program needs to display 10, needs to display 10, so I mean 2 in bit, to the user, to the user. It can remember the this HPA our message. I told you this all in HPA. This one is 1, this one 2, this one 3, like 0, 1, 1, 0, and 11. So HPA encoding and display this one as, let's say again, black. This one instead 10. Okay, so it's mean, just think, when you created one package, and when you put there some bits, and when you represent with this emojis, then if other programs open your package, or if they write you the 10 or the 01, I mean 10 and 11, then just when they write 11, then you will see this emoji there. Or if they write you 01, then you will see this emoji. Okay, there is not bit normally, so they will write you bit background of this way. Anyway, you will understand better later. Let's say black. And computer programs and files, let's do black, this one. Computer programs, yes, and files often need to store multiple characters. That's true for communication, I mean, which they can do by which they can do by stringing. They can do by stringing each characters encoding together. Each characters encoding together. Yes, this is the important point. All we will process together. I'll say program could write a program could write a file called message. You can think like that. HPA. This is the extension of our file. So message. This one is message. This one is our encoding package. Okay, so in our encoding package we have three emoji there with this binary numbers. We know how to represent them, and when other programs or other computers connect to our computer or our program, then they will see there this emoji. Okay, anyway, just I will explain all with this data. Let's come down. I will show you. Yes, this one is 01, 01, 11, 11, and 1010. It will be like that, okay? The explaining will be like that. So for reach to this file or this information, let's look at the other informations here. We will go through this experiment. Let's say a program on another computer on another computer that understands HPA HPA encoding. That encoding can then open message .hpa, right? I told you this is our file extension, and display the sequence of symbols, right? This one is a good information for extension, so we can solve all together to make it. Let's come down and say check your understanding. Check your understanding with our details. All we do together, I think, for solve our problems. Check your understanding. So I will make this one little bit different color because this is the important point. So let's do it something like that. Let's come down and say again we want to work black. Okay, this one will be black, but I don't want to write with this color. Still black, not black. Let's do it and close this place. Okay, let's write something here. Now we'll say what sequence, what, let's delete it, what sequence would the program, would the program display. Let's look at that. Now we will say choose one answer. Okay, let's say this one is A, this one is B, and this one is C. And let's put there our emojis, and let's come here. I will take this emojis, all of emojis down, and let's put them here. Maybe like what, we can do together them to, how to explain, maybe we can put step by step, maybe like, that's right. Let's first do it, and let's come here, tag other one also, this next to next, and what we can do, let's tag this one again here, like tag other one, this one is here, and also let's tag this one to the here. Maybe we can tag a little bit right, this one here, and let's tag this one now next to that, and tag other one can be next to it. Okay, later again tag this one, and just I'm thinking what we can put, just I want to mix them, then later tag it again, really it can be there, the last one can be this one. Okay, and then what we can do, really I'm just thinking maybe we can do two next to next like that, and maybe the other one can be to this one. So I don't know, just I'm thinking about that. The last one is can be this one is two more. Let's do. Okay, our old information here. Let's what we can do here. So I think we can go on together. I will say let's do it black. But why again started this crease here? What about really? I don't understand why this is making something like that, but it's okay. Let's say the and let's delete the other ones down. Okay. Let's close this place. Let's say the HPA HPE encoding only uses 2 bits, right? We know we have 0, 1, 1, 0 like that. 2 bits. So that limits. So that limits, right? How many symbols? How many symbols can represent? Can represent? Just let's come down. Okay. Just we will answer here with our information. Let's think about that. Maybe just I will tag this one here. Maybe put in this kind of place, and let's put some information there. So now you can think 2 bits. Let's come up and look at which one is true. So now we see here our information 010111. Let's come up which one is that. 01. So this one 01 and again 01. So I mean I'm speaking about here 0101 two times. Let's come down what we have two times. Already I saw the answer. Let's come up again for make it easy to understand. Let's come up and check other ones. Okay, let's do a little bit left because really it seems little. Why not go too much? Okay, this place is better. Let's come up and look at the other one 0101 and we have 1111. So I mean 1111 11. This one, this other one. Let's come down. This one is that. So okay, I think we just find answer. Okay, so I mean let's say program for this. This is looking a little bit crazy. So what did you understand here? I'm saying the HPA encoding only uses 2 bits, so that limits how many symbols can represent. So the important point here, what you know, so the important point here, we have two questions for understand concept of displays. The first answer is will be that. Let's do this answer will be with green. Maybe we can do answer is that one. Okay, the true answer is that. Let's come back here and let's write for displays. So let's do anything here. Okay, let's say 4 because 2 bits limits, we have limits for 2 bits, right? So in 1 bits we have two possibility. It can be 0 or 1. I mean it can be true or false in 1 bits, right? So we have two patterns, right? One pattern, so we can think like in 1 bit we have two choices to answer. Can be something true or false. It's something have to go this way or other way. So for that, if we have 2 bits, so we have limits there for 4 symbols, right? We can represent just 4 symbols there. So this is the true answer. This is the 4, not not 2 or some other things. So this is the correct answer here. Let's come down and let's go from here and say, however, with more bits information, with more bits information, information, an and encoding represent enough enough ladders for computers, ladders for computers, okay, to share messages, to no to store messages, documents and web pages. Okay, this is the important point again I'm saying you. So already we have to be careful to understand our concept here, because this information is really critical in your life for computer science. So we will speak as ASCII encoding, then we will speak about UTF-8, and also we'll speak about all kind of this stuff step by step to understand concept, because we have Unicode system, and in Unicode only package, so we know for each country, and so yeah, for each country we have packages to represent with the encoding system. So this is the not encoding system encoding, I mean this I told you. So this Unicode is the just representing packages, but UTF-8 and UTF-16 and UTF-32, they are really packaged for represent this data. But anyway, I will show the all details, and really you will understand this concept when you write some words and you know background of these words. There is some code coming, like different ways, some bits, some bytes coming. So you can think for emoji, we have 4 byte. So when you put there one emoji, when you send one emoji, it will be there four byte message. If you are write some German words, it will be 2 byte message. If you put there some Chinese word or Japanese words, it will take 3 bytes for your information. So when you write 2 Japanese words, it will be 6 byte. I mean, okay, because for normal English words we are just using ASCII. This one is just what you know. It's a standard library, so standard ASCII codes. It's just representing with the 0 bytes. I mean, 0 byte can be 1 byte. I mean, when you see starting with zero something, it is just English words or some kind of things. But if you see there, anyway, we will speak all about that. Okay, I don't want to mix your brain, and we will solve all together in this. By the way, okay. Understand this concept also. The HPA encoding only uses 2 bits. I told you 2 bits. So this one, as let's come up. Yes. So here, this one, 2 bits. Okay, 2 bits can represent there just 4. Why? Because something can be this one 0 or 1. So something like that. Okay, you can think like that. Let's come down. Yes. Now the other subject we will speak. Let's come here. Let's say ASCII encoding. My friends, this is also a very important point, okay? Let's open your eyes, be aware to understand this kind of topics because they will help you in the future when you start to write some program. Really, you will get benefit from this kind of information. It will help you to go through this experiment to be stronger than other programmers. So it will just give you some power of this logic. Anyway, let's start to write something. Yes, my friend, let's start to write. ASCII here, ASCII was one of the standard was was one of the standardized standardized um, standardized encodings encodings. It was it was invented it was invented back back in the right, I think 1960s. So when telegraphy was the primary, when telegraphy telegraphy was telegraphy was the primary form of long distance communication, but is still communication. Say communication. What is this? Communication. Just forgive me if I write wrong. I think this communications like communicate anyway, but it's still in use. But it's still in use today on modern computing. Today, today on modern computing system. So teletypes. It's true. The types something like that. It's would type messages. Would type would type messages on teleprinters. Teleprinters such as this one. Such as this one. Which one? Let's come file. Okay, I think yesterday I downloaded them. Yep, let's come here. Yep, this one. Look at that. Yep, this one here. Anyway, let's. No, it's very big. Let's take it left. And also, what I want to do, let's close this place. Take this information, maybe right here. But this one is very bigger. Have you see? Let's do it. Now, really, it's very big. Okay, I think you got it. Like that. This one is that. Let's close it. This one. So, and say the brand of that. I mean, I showed you. This one is just N ACR 30 33 teletype machine. Teletype machine. Okay. You saw images I showed you. This one, I mean, this brand is just this one. Again, I will notate you. Okay, this one is that. Okay, maybe I can take these images there. Okay, just don't worry about that. Let's come to the maybe here. Let's put it there. Oh, what happened? Let's do it small. Something like that, maybe. Yes. Let's put it there. Let's go to the there. Yeah, this one is that, okay? Okay. This is some details, okay? Just I want to show you, just see what we are doing. Okay. Let's come to the here and go on again. Say the teleprinter would then, the, the teleprinter would then use the, would then use the ASCII, again, ASCII standard to encode encode to encode each typed character each typed character into binary and then into binary and then store or transmit store or transmit the binary data, the binary data. Okay, let's say this page from 1972 teleprinters manual shows the 128 ASCII codes. Okay, the other one is which one, which is other one is that. Now I will put again here. Let's come down. Okay, let's close this one and let's come again here and let's take this one. Yep, put here. It will be bigger again, I know. Yes, just small it. Make small. Yeah, maybe I can put here. Let's a little bit make small it. Okay. Let's do it a little bit more. Yes. It's now okay. Now check it. This one is from 1972. It's teleprinters. Manual shows the 128 ASCII codes here. It's if you check details, I will show you. I think the last Yes, maybe. No, 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 no. Just go back. Okay, this is the some point. Yep, that's right. Okay, the important point here, the displays, check it, one, two, three, and it's all the way going. Then we have 7 bits. Okay, here it's how to count them. 4, 2, 1. Okay, this is for 7 bits place. So this one is, here, if you check all of them, we have 4 bits here and 3 bits here. Okay, so this one is 1, 2, and 3 bits here. Just don't look how much is them. And this one is 4. Okay, this 1, 2, 3, 4. 1, 2, 3. It's totally 7 bits for 120 ASCII codes. And let's come down and we will speak about details. Okay, I will show you all of them. And let's come down because we will speak lots of about them. And let's say, so also we can write the brand of this. We can say ASCII and say chart from terminate printer. Yeah, this one of brand. Okay, let's come down. Say each ASCII characters characters is encoded in binary data is encoded in binary data. Binary, not data, it's using 7 bits. Okay. In the chart, above, uh, the column heading indicates first 3 bits, the first 3 bits, and the row heading heading indicates defined 4 bits. Defined 4 bits. The very first character is the very first character is null. I think you see that. This one just representing 0 and encoded as 0, 0, 0, 0, 0, 0, 0. 7 bits, it's just 0. Okay, let's say the first 32 codes represent control characters. Control characters. Yep. Characters which cause characters which cause some effect besides printing a letter. Printing a letter. Let's do it. Let's say this one, bell Then say encoding in binary as 0111 caused caused an audible and and audible. So which means bell is like there is some sounds coming when you write something saying doot, beep, beep, something like that, okay? You can say audible, bell, or beep, something like that. You can think just that. So let's say the other one is NQ, like that, encoded, encoded as, encoded as 0000101. This one represent represented, I mean, an an inquiry and query, inquiry, a request for the, a request for the receiving station, receiving station, receiving station to identify, to identify themselves, themselves. Okay, let's come down a little bit and say, anyway, if you want, you can check here what I speak. This one is bell here. Okay, the other one is, we have different one. Okay, I will show you all. The null here, it's 0, and we have bell. If you check bell, it's like that. Okay, let's come down, and we have NQ, it's this one. Do you know what it's about? It's just inquiry, a request for the receiving station when they press it, and just they're doing something like that. Let's come down and say the control characters were originally characters were originally designed for the teleprinters, right? And and telegraphy. But many have been, but many have been, but many have been, many have been repurposed for modern computers. Repurposed modern for modern computers for modern computers and and the internet the internet especially especially, let's say this one and this one. This is the important point. This represented a carriage return. Come down. Carriage return. Let's say like that. Okay. Return on. Why? Just do this. Okay. On teleprinters moving. The printing head to the start. The the printing head to the printing the printing head to the start of the line. Yes. And say LF. This one is like 00010. It's represented a line fit, right? Line fit. Moving to printing head down. Moving to printing head down. Head printing head down. One line. I mean, okay, one line. Say modern internet protocols. Modern internet protocols. I'm speaking about HTML, so HTTP and FTP and SMTP, such as I will give you now HTTP, FTP, SMT, SMTP use combination of this and this. So have you got what is that? So this first one, you can understand really what we're adding here. The first one is LF is line fit. The other one is, this one is carriage return. It's like, anyway, I will give you one example here to understand this meaning of this very good. Let's come here and say, sorry, to represent the end of lines, okay. The remaining 96 ASCII characters look much more familiar, already, right? Familiar. Okay. Now let's come down and say, here are the first 8 uppercase letters. Okay, let's say here binary. Let's maybe binary, and say for here characters. Okay, let's come down and do something like that. Okay, and really just do this one is 10000001. This one representing just the A. Okay, other one is 10000 all the way, not like that. It's 10. You know this is what, right? But I think this is not 1, 3, 4. Right. Yes. And this one is just B. And the other one is all the way going like that, okay? 1, 0, 0. Yes, and 1, 1. The C. Yep. And the 1, 0, 0. Say. And what will be here? What do you think? And just say 1, 0, 0. Because this is, just think this is 64. 64 flat, plus 8. It will be 72. 72 representing D. Okay. So 64, no, 65. This one is here. 65 is represented A. 60, 66 here is representing, I think 66, no, I will check now. Yeah, 66 is representing B, 67 representing. Anyway, I will check it. Maybe I'm wrong. I don't know really. Here we have 64 and 64 plus 3. It's 67, sorry, 67 represent, no, maybe really I will check it. So I just want to give, but what is it really? 1 minute, 7 power of 7 power of 2. Okay, this one is, we can think like 64. 64 plus 1, 65, it's representing A. 64 plus 2, 67 is B. And 64 plus 3 is 68, right? 4, 5, 6, 7. I think 7, all right? And we have 64 plus 8. 64 plus 8 is 72. My brain is a little bit mixed because today I worked 14 hours and really I'm not feeling too much good, but we will together all of them, okay? Sorry. Let's do the other one is will be 1, 0, 0, 0 and 1, and it will be 1, 0, 1. It's something like that, and this one will be A, E, I mean, let's do E. And this one 1, 0, 0, 0, 1, 1, 0 will be to the F. Okay, let's come here and say 1, 0, 0, 0, and say 1, 1, 1. This one here. Let's say this one will be G, and the other one will be 1, 0, 0, 1, 0, 0, 0. This one will be H. Okay. Let's look at details. This is 64 plus 1. It will be 65. The other one 64 plus 2. 66. It's B. And 64 plus 3. 60, 67. C. And 64 plus 8. I think 4, sorry. 64 plus 4. It will be, right, it will be 68. And this one is D. 64 plus 5. And it's going all the way like that. E, F, G, H. Anyway, let's come down and say following the ASCII standard, we can encode we can encode we can encode for ladder message. Yep, into binary. Into binary. Yes. Now I will write something. I hope you can find the true answer. Let's try it together. Okay, let's do it. 1 0 0 0, maybe 1 1. Other one 1 0 0 1 0 0 0. Other one 1 0 0 0. Yes, then 1 0 1. Other one 1 0 0 0 1 1 0. What do you think about this message? What I did here? What I wrote here? Do you have some answer? Okay, let's come down. We have some answer there. We have some choice there. I will say check your understanding. Okay, let's do it a little bit like that. Let's close it here and really just we'll write again in the same color. What word what word does that ASCII encoded binary data represent. Yes, let's come here. Choose one answer. Okay, I will give you a chance to look at again above of this place, but before I will just do here the answer. This will be A, this will be B, this will be C, and this will be D. Okay, let's look at first one. First one will be it's B8 beat, something like that. The other one will be fade, and the other one, let's delete 0. Now come here. This one will be cafe, and the other one will be chef. Chef. Okay, what do you think? Let's come up and compare them. The first one is 64 plus 3, right? 64 plus 3, 60. What it will be? 67, right? 64 plus 3 7, 67. So this is 65, 66, 67. This one is C. The other one is just I am seeing here, it's 8. 64 plus 8, it will be 72. And if it is 67, this one is 68, 69, 60. So 69 and 70, 71, 72. This one is H. Then we know we have C, H. And this one will be 5. And let's come here. And this one is A. And it's all the time. So it's going to be chef. So really, we can write some message. We can represent this binary codes to represent with these numbers already there. You know, in ASCII code, we have we represented this number in 128 in data, in binary data. So, okay, let's put there the answer like that. What I want to do, let's come here and do this one is chef. This one is true. Let's come back to here and let's go down and we will go on again.